Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about scientific testing. This is a very critical aspect that we must understand thoroughly. So let's dive right into it. Well, first you have to understand one core concept. Science is not man-made. We humans did not make science. We just call it science. It's basically man-discovered. Think of it this way. You say Mount Everest. Does that mean Mount Everest did not exist before you named it? No, it was there. It's just you did not know it. You did not discover it. That's the whole reality of science. So science has no limit. Be mindful of that. When somebody says, oh, science can't explain it. No, that simply means we can't explain it. That simply means so far, at this point in time, when you're making this claim, we have not figured it out. That's what it means. So be mindful. Try to avoid saying like, "Oh, it's beyond science." That simply means we have not understood it. That's much more accurate description. Now, science is so thorough, so realistic. Again, it's a reality itself that you can deal, like you can make a mathematical model while managing known things. Like basically, let's say it's like a plus b plus c equals 25. If you know 2, you can handle that. So same way, science is also like you can handle known and unknown at the same time. For example, if you studied periodic table or looked at it at any point in time, you're like, dude, this is very well organized. Here's the interesting fact. The person who laid it down did not had all the elements that we have now. So using mathematics, using the fact of science, of reality, is like, I'm doing the maths, and it predicts that there should be something here. So he's like, he left empty spaces in periodic table. Yes, deal. After his death, we brick by brick started to fill it up. So be mindful. Science allows for known and unknown to exist at the same time. You do not have to, oh, we don't know everything. That does not matter. Like we don't know what basically electrons are made out of. Well, basically we call it a fundamental particle, but it has to be made out of something. Like you can say that. And what happens if you break it? We don't know. But does that mean we cannot make television, cameras, microphone? That's the reality of it. So be mindful. Don't try to fall into the, oh, we don't know everything, that means we know nothing. Like we are not Jon Snow yet. So how the heck you take science seriously? What allows science to be basically better than any dogma or any religion? Reality is very simple. Science, it works, bitches. Now, yeah, Darwin was like, he went awesome with this. Basically, Richard Dawkins. So reality is science allows us to make prediction with accuracy. Now these two words are very critical. Basically, think of this: I'm gonna make a prediction. There's gonna be earthquake. Any Tom, Dick, and Harry can make that prediction. Any Tom, Dick, and Harry who has the ability to know that Earth has a tectonic plate. Tectonic plates constantly moving. That means sooner or later there will be an earthquake. And if you know the fault line, you can claim, in future there will be earthquake in this fault line. That does not mean any goddamn thing. You have to be accurate with it, or even precise. What does that mean? That means, think of this way: when Newton was there, when he was alive, people are not taking him seriously because, again, it's Newton. Why would you take him seriously? Like, we know his value now, but back then people did not. But here's the deal: he did something very clever. He's like, my maths is true. I did the equations. I did figure it out. There's supposed to be something like this, a comet or whatever, magic, supposed to happen at this point in time, in this position of the sky on this date. He's like, he went precise on this stuff. Like, you're gonna stand on, let's say, 6th November at 6 p.m. You're gonna notice it here exactly, and it will be stay there for till 7 p.m. Now here's the, before this, people were there who were making prediction, but none of them were accurate. And this dude is this random dude is like, no, this is exact time, this is exact location of it, because he added accuracy there. And then that's how people started to take him seriously. That's how we know science is real. It makes prediction into the future with accuracy. Now again, when I say accuracy, it does not mean absolute. It means good enough. Basically, if you're saying 6 p.m, 560, 560, I'm saying that's literally that. 549, 545, you will have a bit of fudge factor. You'll always have fudge factor. But compared to that, in some day in the future, this will happen, versus, oh, on 6th November, this will happen. Be mindful. That is the easiest way to figure out whether something works or something does not, if it makes prediction with accuracy. So let's go down. Now there are layers of it. First, we have layer known as laws. These are absolute. These work. Even if you don't know it, these law will work. Like action equals reaction. It's absolute. But here's the law is just that. It is. Why it is, we do not know. So to handle that part, like why it is, we build hypothesis. This is layer 1. This is step 1 of doing something. We start with the hypothesis. This is why. Like life is there. That's you can even call it a law. Life is there. Absolute reality, absolute truth. Gravity, law, truth is there. How the heck it is there? Now that you will start with hypothesis. and you will start trying to prove it and disprove it at the same time. Now reason for that is very critical. You must make something that is falsifiable. Basically, if my hypothesis is true, this will not happen, and if this happens, that means my previous hypothesis was wrong. You must be in a position where you can create a falsifiable situation. If not, nobody will take you seriously. For example, I can claim, if you count feathers of every single bird known to mankind, and present at this moment in time, the total feather count would be 2 billion 3866. Like, I can give any number. Here's the deal. How would you disprove it? You can't actually go and count every single feather. You can't disprove it, so people will just laugh me out of the room because it's not falsifiable. That is one very critical requirement. So you cannot be vague. You have to give a point. Okay, if this does not come, then I will take my equation out of the game, my hypothesis out of the game. It is very critical. Now, after testing, once you reach that point where you're like, if this happens, then you're gonna test it, obviously. Then you're gonna do what we call peer review. Peer review simply means other people will take a look at your work and they will try to disprove it. And this is a very good thing. This is not a bad thing. This is awesome, because truth survives the test of time. Then you're gonna do some more testing. This is very critical. The more testing you do, more thoroughness you get into your theory, and more absolute it becomes. Now, all hypotheses become theory. At that point in time, this is proven. At this point in time, this is real. However, all theories have limitation. It's not a law, it's a theory. What does that mean? That simply means Newton can come along. Newton is like, this is gravity. This is the maths that describes it. And then he could have a problem. It's like, dude, you can't explain. Your mathematics cannot explain Mercury's orbit. He was like, let me, it was unfalsifiable. Like, if you can't explain Mercury, that means there is something wrong. He went back to the drawing board. It's like, okay, let's figure out calculus. And then he's like, ta-da! Now our mathematics, while following the same hypothesis, works. Now we call theory of gravity. Now Einstein comes along. It's like, good stuff, but it does not predict very far. Like, in terms of mathematical models, you can't predict in like a few billion years ahead. So it's like, what if gravity was bend of space-time? Whoa. Now here's the deal. What does that mean? Does that mean the equations created by Newton was wrong? No, it was a 2 megapixel photograph. When Einstein came along, that 2 megapixel went to 20 megapixel. Basically, his prediction was, it was good. This was better. What if in the future somebody else comes along? It's like, no, I'm gonna go even down. I'm gonna go to quantum gravity. Basically, explain how time flows. At that point in time, we'll go from 20 megapixel to 200. But does not mean all the previous one are wrong. Basically, previous one are just lousy tools. Are they accurate? Yes, only then they can cross the threshold of testing, peer review, and prediction. If they are there, our prediction will go from this exact moment in time to this exact moment in time 50,000 years from now. Our precision will go that far out. So this is a very critical aspect. Hypothesis means step one, you started something up. Theory means we have tested it within reasonable and it is accurate enough that we can move on to doing something better. And that's why I specified math. Basically, you can work with known and unknown at the same time. So Newton's mathematics will work absolutely without knowing the fact that there is space-time. So this is a very critical aspect. Now, testing. Now, this is the way we figure out from faith, hypothesis, or some hoo-ha to actual truth. Now, only way to find out truth and limits. Now, this limit part is very critical. Same way Newton went back to, it's like, Mercury is pushing the limits. Like, I do not know how to explain that. Then he has to solve some problems. So same happens. Every theory, every hypothesis. Let's say at this point in time, we are saying theory of relativity. Awesome sauce. Here's the deal. Does it explain what happens at the beginning of Big Bang or at the point of black hole? No, that's its limit. If you make something truth, it will always have a limit. It's like, dude, this part is like, bro, I'm out. For example, like you can take a normal matter laws, logical law, like this thing will not magically disappear and go to other side. Go to quantum physics, is like, bro, that's Tuesday for us. So reality is there is always a truth and a limit. It's like classical physics has a limit. You go below that, quantum physics, there is different laws and different limits. Quantum physics, teleportation will not apply on large big bodies. So that's how we figure it out. Truth always comes with limitations. Now there are ways to do the testing wrong, basically. So that simply means there are also good ways of doing testing. If you mess the testing part up, anything else does not matter at that point in time. Testing must be done properly. So there are very good options we have nowadays. We have developed what we call double blind test. Is one of the best. Now does not mean it's the best of the best. It's just at this point in time, this is our good tool. So what does double blind means? Simply think of this way. Let's say there is a medication. It's like, okay, this medication is gonna take care of the pandemic. You're gonna take a doctor. It's like, okay, you're gonna administer a medication that we are working on, and it's gonna take care of the patient. It's like doctor is like, okay, cool, I'm agree, I'm happy. Then you're gonna take patients who are sick with that disease, and it's like, okay, you're gonna receive a testing medication, and they are like, okay, awesome. Here's the you're gonna give medication without telling the doctor. You're gonna give one medication that is just placebo. You're just gonna put vitamin in that, and the actual medication on something else. Nobody knows which what guts what. Basically you will know, but doctor would not know, nor the patient. So basically test taker and test giver will not know what the hell is happening, and that is a very critical double blind test. This way you can remove placebo. This way you can remove many false positives. You can remove, like, you can filter out so many things. You will be like, whoa. So this is one of the good tools. Like, for example, we had this recently in my family. Is like we changed our milk vendor from one company to another. My mom said, test it out and, like, tell us whether it's good or not. Here's the deal. That was the wrong thing to do, because to proper testing would be like, she did not tell me like she has changed the milk, and if I, while drinking it, I was like, something is different in this. That means it's tangibly different. Now she told me, now like, what is the taste? Is it feel like, my personal bias is messing up the result. That's why double blind is important. Now, once you do the testing, you don't be like, okay, I've done the testing, I'm happy, I'm going home. No, that's your step one. Now you do multiple times, and you do it in different condition, and then you change factor one by one. For example, let's say you take a metal bar. It's like, this metal bar, this alloy is good. You test it. Everything awesome. Like, I can drop a 10 kilogram weight on it, and it's like, boom, I can handle it. I'm not gonna bend. Here's the deal. What happens if you increase the temperature? Now you raise the temperature 200 degrees Celsius. Metal is like, bro, I can do this all day. Now you take the temperature to 600 degrees Celsius. At this point, metal starts to bend with the same impact, which is what handling without any issue. And you're like, okay, upper limit is that. What happens if I go it colder? You're like, okay, what will happen? Let's just, for the lol sake, let's make it minus 70 degrees. Here's the metal pipe deformed permanently. You're like, okay, let's try a new piece. What happens if I go down even in lower temperatures? Like, you are thinking permanent deformation. Here's the, it shatters like a glass at minus 200 degrees Celsius. That's why you test many times, and you test with multiple conditions, and you change the factor one at a time for management reasons, and boundary condition must be established. You will figure it out very quickly once you start to do something. It's like, boundary conditions are very important. It's like, that's why I specify classical laws, classical physics. Everything that we take and know for granted does not work in quantum mechanical world, because that world is outside that, basically boundary condition. So this is very critical. This is how we figure out testing itself. Now, what about data? Testing generates something. It generally generates data. Now, this is the most messy part, most dangerous part about science. Is basically, more data you will collect. You will think, more data, more awesome. Here's the deal. It will become more messy. And if any of you have done any experiment in school where you are taking the temperature of, like, let's say you heat a 1 liter water for around 100 degrees Celsius, and it's like, start to see plotted down like how quickly it cools down. You will think book will give you a graph. It should look like this. But here's the deal. When you actually measure, it's like tick tock, tick tock, tick tock, tick tock. What the hell is happening? So here's the deal. Real life is messy. Everything is messy. So more data you collect, the more messy it will get, and managing it is very critical, because you have to understand this very thoroughly. No test can give infinite precision. For example, you take a unit. Basically, you printed, let's say I have a 3D printer, you printed a cube. It's like 2 centimeter. Awesome. Here's the, how do you know it's true? You measure it with a ruler. Okay, you take a better caliper. At this point in time, it would either become 2.0001 or 2.0002, something like that. Here's the, but if you take even better measuring equipment, the equipment used by NASA and all that jazz, at this point it is like 1.9999927. Things like that happen. Infinite precision is not achievable. That's why you have to be good enough. You'll be like, okay, 2 centimeter within, if you see any mechanical drawing, any engineer drawing, they will say plus and minus 0.2% or plus and minus 0.02 if they are good. So that's the whole point. You have to be mindful of this. You have to be aware of the fact that there is no infinite precision. And now the most dangerous aspect of this, poor data management can give false result. Basically, you can do everything right. You can have a true hypothesis, you can have proper testing, but you messed up the data stage, you can have false results. Now, this aspect is, people who know this system, they can manipulate the same result and give you a false claim. Now, there is a book specifically dealing with this, which is called Merchants of Doubt. Basically, Merchants of Doubt. Same scientist as in, like, in their job profile, basically, okay, I study atmospherics. You can have 10 good scientists who are like doing the research properly, doing everything done, and they are coming with this result. Let's say x equals to y. Now, another scientist which is like, I'm gonna sell my soul for money, and they'll be like, okay, I'm gonna take the same result, I'm gonna mess it up, not the testing, not anything else. So you can discredit them. It's like, dude, this is your testing result, and they're gonna mess it up in a very interesting way. If they know what they're doing, they can mess it up in such a way that you will never be able to figure it out, like what the hell they messed up. So at that point, you can take the same result, basically same data that you got from the multiple testing you have done, and you can manipulate the outcome. People are like, whoa, x equal to z now. Well, this happens. This is the very painful part of our science. That's why people don't agree on even on something as science. It's like, yes, it's true, yes, it's absolute, but because we are humans and data management is messy, you can take the same data sample, especially on complicated subjects, and be in a position where it's like nobody agrees. That's a very unfortunate reality of the situation. So how do we manage against this? Well, first thing first, we have filters. Now, first filter is very interesting about this. Keep your mind open, but not so open that your brain falls out. Now, I cannot tell you how many times I have not practiced this in my day-to-day life, and I was such a big fool that, like, seriously, I made of, like, I believed in hyperloop hype and solar roadway, like, whoa, solar roadway will actually work, without my brain thinking, it's like, wait a minute, it's a road, there will be cars on top of it, how the heck it will generate it, because there will be shadow on it. It's like, again, that happens because I kept my mind open, maybe this could save us, and my brain fall off. This happens to best of us. We are humans, so be mindful of this. For example, I recently had a per individual commenting about, like, don't microwave your food because that will make it harmful, destroy it and all that. So I kept my mind open. It's like, but I did not let my brain fall off. So this time I was like, okay, let's figure things out. What is microwave? Photons. Okay, photons, let's classify it more. It's inside a spectrum which call band, microwave band. Okay, cool, awesome, we got that. Let's put it aside. What he's saying is safe. Cooking on a gas stove. Here's the what is happening at that point. Infrared is happening. Like, you are cooking it, your convection and radiation is also there. Infrared is there, especially in open flames. There's a lot of infrared there also. And it's like, okay, infrared, let's put that photon next to microwave. Here's the deal. Infrared is far more powerful than microwave. Again, it's a higher in the spectrum. Here's the deal. If infrared is not breaking the food molecules and making them toxic, how the heck microwave can? But another aspect could be there. What if the intensity could be high? You can have a scenario where, like, normal light, let's say red light, can cut metal if intensity is high enough. That's how we do laser cutting. So what if that part is there? Here's the deal. A normal flame, the gas stove, it's going like 5 or 6 kilowatts of heat energy. The energy consumption of your microwave does not reach that point. So that's not there flat out. I know for a fact that photons are low energy. Photons do not have enough photons in them. Basically, the oomph amount of there is not there, so it cannot damage it. Then I push it to for boundary condition. At this point in time, what do we do after that? We use gamma radiation to sterilize food. At this point, this is the highest energy photon possible, and we are using it to sterilize food. Now, here's the, who do we give this food to? We give this food to people who have immunocompromised, or they are going through radiation therapy. Basically, bad food equals death in that case of scenario. They're not going to get loose motion, they're going to be dead. So here's the deal. Somehow they survive, and they only survive on this. That inherently means you have to go bonkers with radiation, like on a god tier level, or flat out put things that have radiation in them in order to use radiation or photons to contaminate a food or make food toxic. That's how, like, I kept my mind open. Maybe I'm wrong about it. Like, I did the calculations, like, flat out, no. So that's why very critical. Be open to things, but be mindful. Don't let your brain fall off. And one of the best filter that has never let me down, if it's too good to be true, it probably is. Now this part, if you're old enough, reaching 30s, you'll be like, dude, I got this. So if somebody says, I'll give you a warp drive, we're gonna have faster than light travel, it's like, call me up when you actually do it. It's like, EM drive, no material required, magic. Call me when you actually do it. Magical diamond battery, gonna charge your mobile phone forever. Call me when you actually do it. That's it. Like, once you reach that point, I have made videos on all these topics, and you can watch them down below. It's like, if it's too good to be true, generally there is a condition applied. Generally there is like, okay, this, if that, and no, in real life things work. That's why I specified, even with a lower resolution theory, it will still work. But when you have magic, voodoo, hula la la, none of them will, right? Like, if else that would, and people like in 1600s, bro, we figured out many things. So reality is, if it's too good to be true, generally it's like, yep, no. Now, another aspect of the human part, that's why I specified it's problem with us, not with science, with us, is that blind trust happens. Now, for example, I used to trust Thunderfoot a lot, and he's an actual nuclear physicist. He knows his stuff, undeniably tested. But here's the deal, he was talking about politics, and I was like, oh, I trust him for this, so I trusted his political aspect. I was like, and he was wrong. And I was like, how the heck that happened? Because of my blind trust. I trusted. I should have been like, okay, if he's talking about nuclear physics, I'm like, pay attention. If he's talking about politics, no, you could nuclear physics, call me up. Whenever you're talking about politics, I'm not gonna pay attention, because again, that's not his field. So reality was my blind trust was making me fool. And another aspect is personal bias is very harmful. For example, you could take the result. This goes back to the same a merchant of doubt. If you don't want to believe into something, you can take the data, because data is messy, and you can be like, oh, this winter was cold, and that's why I know this. That happens. Personal bias is very harmful. If you want to believe in magical scenario where we live in a world where our mobile phone never runs out of charge, you will believe in magical nano diamond battery and la la la, which nobody has actually built it. Nobody has actually built it. It's like, oh, this is gonna change the world in few years. Build it first. Build the goddamn battery first. It's like, oh, we are tested with nickel. Again, you're supposed to build diamonds with carbon, not nickel. So that's the whole reality of it. Another aspect, don't be too harsh on yourself, because this will make you a bit too jaded, and this may end up closing your brain, and you may end up missing something that was quite obvious. It happens. We are human and we are flawed. Be mindful of that. Like Einstein can make a mistake, Newton can make a mistake, every Tom, Dick and Harry ever born can make a mistake. It's normal, it's real, it's human. So be mindful of that. Just take a deep breath, relax, apply some tricks, and if it's too good to be true, generally it is. So this was my presentation on scientific testing. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me your disappointment. Please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.